Okay, so the next question that we have is a line passes through basically these 2 points, x1 comma y1 and h comma k and h comma k. The line passes through these 2 points. If the slope of the line is equal to m, you want to show that k minus y1 is equal to m times h times h minus x1. So what that means is that if a line basically passes through these 2 points, basically x1 y1 and h and k, h comma k, and if you take the slope of the line as m, then you want to show that k minus y1 is equal to m times h minus x1, and that is actually the equation of a line as we will read later in this chapter. So basically, if based on these 2 points you can calculate the slope of the line, we said that basically m is equal to basically y2 minus y1 over x2 minus x1. So over here you can write m is equal to, basically you can take this as x2 y2 and x1 y1. So that would be k minus y1. The denominator becomes h minus x1, and that is the slope of your line, and it is equal to m. So then what that means is that if you cross multiply, you'll get m times h minus x1 is equal to k minus y1, and of course that is again the equation of a line that we will study in this chapter, I suppose. Now the next question that we have is, if 3 points h comma 0, a comma b, 0 comma k lie on a line, show that a divided by h plus b divided by k is equal to 1. That is again one of the forms of the equation of a line or something like that. I suppose it was something like parabola or something. I don't remember what that was, but basically you have these 3 points h comma 0, and then you have a comma b and 0 comma k, and these 3 points lie on a line, meaning that they are collinear. You want to show that basically a over h plus b over k, is equal to 1. So if these 3 points are collinear, that means that, suppose that for example this is a line and this is the 3 points, for example let's say h comma 0, this is a comma b, and this is 0 comma k. If these 3 points are collinear, what that means is that if you suppose that basically these 2 points constitute a line, and if these 2 points constitute a line as well, the slope of this line over here is equal to the slope of this line over here, because the 3 points are collinear. So what you can do is that find that the slope of the line going through going through these 2 points, also find the slope of the line going through these 2 points. And of course, since the 3 points are collinear, you can equate them, meaning that you can say that the slope of this line is equal to the slope of this line, and most probably you will get this equation over here. So let's see what happens. So if you have h comma 0 and a comma b, the slope of this line is basically m is equal to, or basically let's call it m1 is equal to basically b minus 0 over a minus h. Now if you have these 2 points, a comma b and 0 comma k, the slope of this line is going to be m2, for example, is going to be k minus b over negative a, 0 minus a. So now if basically based on the fact that these 3 points are collinear, I can write m1 is equal to m2. m1 is equal to m2, which means that b over a minus h is equal to k minus b over negative a. And that means that negative ab is equal to a minus h times a minus h times a minus h times k minus b, and or you might have to take them in a different order to get to this. I'm not really sure. Let me take a look at the solution here, because so here basically we have b minus 0 over a minus h is equal to k minus b over negative a, which means that negative ab is equal to k minus b times a minus h. And so if I write this as, it seems that what I did was not actually wrong. So that means that negative AB is equal to basically AK minus AB minus KH plus BH and okay, so over here we have so I can simplify this by writing basically negative AB and negative AB you can cancel out, so that means that AK plus BH minus KH is equal to 0, and is equal to 0, and here you have AB and KH. So I can write this as AK. I can write this as AK plus BH is equal to KH. And if I divide both sides of this equation by KH, meaning that AK over KH plus BH over KH is equal to KH over KH. K and K cancel out, H and H cancel out, and you will get A over H plus B over K is equal to 1. And that's basically what you were looking for. And what that actually means is that if there are basically, suppose that you have a line over here. Suppose that you have a line over here, the y-intercept of that line is 0. That means that you have some line on the x-axis. I'm sorry, some point on the x-axis, and some point on the y-axis, and some point probably in the middle between those 2 points. If these 3 lines are collinear, then you can say that A over H plus B over K is equal to 1, meaning that the x coordinate of that point, which does not lie on either of the axes, the x coordinate of that point divided by the x coordinate of the point which lies on the x-axis, if you add it to the ratio of the y coordinate of the same point not lying on either of the axes by the y coordinate of that point lying on the y-axis, that gives you 1, which is basically what we have over here. Now what you can do with this depends on the different situations that you might come across, which we will see later. So that is basically that. And there is another question over here. Consider the following population and year graph. Find the slope of the line AB, and using it find what will be the population in year 2010. Okay, so we have a graph over here. First, do some. So we have a graph over here. So as you can see, we have this graph over here. This is population in crores. Crores is basically basically crore is, I always get confused with these crores and lakhs and everything. So a crore is basically based on the Indian number system, which is another way of using the same decimal number system that the same decimal international number system. In the international number system, we write our numbers as, for example, we have 3 digits over here, and then another 3 digits over here, and then another 3 digits over here, and then another digits over here, and so on, and we can just keep going in this direction. So this is ones, tens, and hundreds, and then this is basically thousands. This over here is the million, and this over here, this part over here is the billion. Okay, and you're already familiar with this, with the way that we write numbers in the international number system. We write for example, so if you for example pick 9 digits over here, you can go all the way up to 999,999, and then 1 million becomes basically this number over here, and all of these becomes zeros, and then this becomes a 1, and then you can just keep going in this direction, and then add more numbers to this to get larger numbers. But then in the Indian number, in the way that Indians write numbers, it's a little bit different, meaning that you have the same 3 digits over here. I mean, the way that they separate these digits is different, and then they have different names for these different basically separated digits. So they have the same 3 digits over here, but then over here, you have basically 2 digits. After that, you have 2 digits. After that, you have 2 digits, and so on and so forth. And this is this over here is thousands. Okay, this over here is 1000, and over here you can go all the way up to 999. Up to here you can go all the way up to 99,999. But then as soon as you get over here, which becomes basically, for example, 1,00,000, this is 100,000, which is basically 1 lakh. So this is called 1 lakh. And you can go all the way up to 99 lakhs here, which is basically 9,999,999. And then once you pass that threshold, you'll get to so up to here you can go all the way up to 99 and 99,999, which is another way of writing basically 9,999,999, which is 9,999,999. But then as soon as you get over here, then all of these become zeros, and this becomes a 1, 0, 0, 0, 0, 0, 0, 0. And this is called 1 crore. This is called 1 crore, which is the same thing as basically 10 million. And you can go all the way up to 99 crores over here, and you can just keep going. So that is basically 1 crore, which is the same thing as 10 million. So now 1 crore, basically, that is basically the whole story behind that. Now, what we have over here is the population in crores. For example, 87 crores is basically 870 million. 87 crore would be, I suppose, 870 million based on what we said, and so on and so forth. And so you see the population in crores, and then this is the year. So 1985, 1990, 1995, 2000, 2005, 2010. And you see that this is a straight line. So since it's a straight line, the population in 2010, of course, is supposed to be along this line. So if, for example, if you have these 2 points on the line, which is 1985, for example, 92, and 1995, 97, this is 97 crore people, and this is 92 crore people in these 2 years. If basically the other point on this line is going to be collinear with these 2 points, so you can easily calculate what the population is going to be in year 2010. So in year 1985, the population has been basically 92 crore people. In 1995, the population has been 97 crore people. And so in year 2010, the population is going to be some amount, some crore, for example, people, which you can calculate. So what you can do is that you can, since it's a straight line like this, since it is a straight line like this, and basically, for example, let's say that this is point A and this is point B and this is point C, you can say that this is point A and this is, for example, point B and this is point C. So if I calculate the slope of this line AB, or this line segment AB, so the slope of AB is going to be, you can take this as the population, you can take it as the output or the y-intercept of these points, and this is your x. And you know that the slope is basically equal to y2 minus y1 over x2 minus x1. So these over here are your x's, these are your y's. Excuse me. So what I can write for AB is that I can write it as, basically, I take this as 0.2, take this as 0.1. So over here I'm looking for y's over here. So 97 minus 92, 97 minus 92 over 1995 minus 1985, which is the same thing as 97 minus 92 is 5, and that is basically 10 years, 1995 to 1985, so that's 10 years, which is equal to 1/2. So the slope of this line segment is 1/2. Now the slope of this line segment is supposed to be the same as this, is supposed to be the same as the slope of this line segment. So the slope of basically BC is equal to, basically, again, you go for y's over here. So for example, 0.1, 0.2, I write this as x minus 97, x minus 97, and 2010 minus 1995, and that's equal to x minus 97 over 2010 minus 1995 is equal to 5 years over here. That is 5 years over here. I'm sorry, 15 years. To 2010, 1995. So you have basically 1, 10, 9, 11, 10, and 10. So you have 5, 1, 0, 0. That's 15 years. So since they are since the slope of these two line segments is supposed to be the same, so I can write basically x minus 97 over 15 is equal to 1/2. So if I cross multiply, I get 15 is equal to 2x minus 2 times 97 is equal to 180. 180 plus 14 is equal to 194. So 2x is equal to 15 plus 194. 194 plus 15 is equal to 204. 2x is equal to 204, so that means that x is equal to 102. X is equal to 102. So over here your x is equal to 102. That means that in year 2010 the population is going to be 102 crores, basically forecasted by this rate of change that has been the case during all the years from, for example, from 1985 all the way up to, for example, I don't know, all the way up to 2010 that we have here. So during all of these years. So that's basically how you can solve this problem. So x is equal to 102. Number 14. And it seems that I have made some sort of mistake here. So the 1/2 and x minus 97 and 2010 minus 1995. So x minus 97 over 15. And x minus 97 by 15 is equal to 1/2. And so 15 is equal to 2x minus, let's see if I made a mistake over here probably. So 97 times 2 is equal to 194. 194. That means that 2x is equal to 15 plus 194, which is equal to 209. Oh, okay, that's where I've made the mistake. That's 209. That is 209. That means that x is equal to 209 divided by 2, which is equal to 104.5 crores. 104.5, which is the correct answer here. Okay, so that is basically all of these exercises. Now in the next part we will talk a little bit about the various forms of the equation of a line. And so I will see you in the next video. Thank you.